I both love this video of the blood vessels in a leech, but I'm also extremely frustrated by it. So first, this reminds me that while when we think of blood vessels, we're often thinking of blood vessels in humans or other larger vertebrates, that blood vessels and hearts can be found in invertebrates as well, including worms. And worms are perhaps good to focus on, since it would have been worms and worm-like animals which first evolved blood vessels and hearts. So, there are worms which lack blood vessels. Flatworms do not possess them, and nematode worms do not possess them. But then there are other worms, such as annelids, and that would include leeches, which possess blood vessels and possess hearts. So a heart is a contractile blood vessel. And so earthworms, for example, possess contractile blood vessels, which we call hearts. Here in this leech, you can see the blood flowing through blood vessels because of the pigments involved. Invertebrates can have a number of pigments which bind oxygen, and thus, just as vertebrate blood can be pigmented because of hemoglobin, which makes it look red, invertebrate blood and fluids may possess pigment as well. So here you can see pigmented blood being pumped through the body of this leech. And this, makes us think about the origin of blood vessels in worm-like animals, which would then be modified in their more derived descendants. But that then gets to the frustrating part of this, because one asks, how many times did blood vessels evolve? Well, because I'm older, when I used to teach anatomy, the majority of biologists classified the groups of invertebrates in one way, which would suggest that blood vessels only evolved once, so that the worms which lack blood vessels, such as flatworms and nematodes, would be more primitive. Blood vessels evolved once, and thus all of the organisms which would have blood vessels and a heart. This would include mollusks, arthropods, annelids, and then the chordates and vertebrates, that these would all have inherited their circulatory systems from one common ancestor. Unfortunately, genetic analysis has now produced a classification system which was different from that earlier one, which used primarily anatomical features. And so now there are two options which are both a bit confusing. Did circulatory systems evolve multiple times in groups of organisms, so that the circulatory systems of mollusks, arthropods, and annelids might not have a different origin than that of chordates? Or did, once again, blood vessels and hearts evolve once, but now some of the groups of animals whose ancestors had blood vessels and hearts, did they then lose them? So would their absence in flatworms and nematodes be the result of a subsequent loss of an ancestral feature? That has not yet been resolved. And so in science, we are often struck by, when science works correctly, you often have to discard the conclusions which you used to hold, because new evidence has then challenged those previous conclusions. But now also this opens up new questions for subsequent research. So the scientific approach to the world means that we will have to continue to study it and continue to question the conclusions which we had already had, and then maybe discard conclusions which we once had confidence in, and look for new explanations in light of new evidence. That may be a bit more frustrating, but without it, we wouldn't have our current scientific understanding of how the natural world works.